Now the next set of statistics now that we're going to calculate, I'm going to show you how to calculate. Indeed, these are statistics that you would look at if you were interested in kind of the portfolio effect. What would happen if I put both these assets on the same balance sheet of a corporation, or if I put both these assets into an investment portfolio? Now you'll see again now, these statistics, the root of it now is the deviations from the mean. And we're going to use these two columns right here that we calculated just in a previous video. And we're going to use the deviations of the security and the deviations of the market. Now, the first statistic we're going to look at that looks at the interrelationship between the assets. This is known as covariance. Okay? Covariance can take on any value between negative infinity and positive infinity, a fairly wide range. But nonetheless, it's known as covariance. And covariance is defined as the mean of the product of the deviations. So again, product means multiplication. We're going to multiply the deviations together, and when we get all the products now, we're going to find the mean of that. So for the first quarter here, the deviation for the security was 3.67. The deviation for the market, 2.33. If you multiply those two numbers together, you get 8.56. And just to go through one more, in the second quarter, the deviation for the security was a negative 6.33, and for the market, a negative 2.67. Multiply those together now, a negative times a negative is a positive. So if you multiply those together, you get 16.89. And again, I did that for every quarter, every set of observations that we had. The deviation of the security multiplied times the deviation of the market. Covariance is the mean of the product of the deviations. This is a historical distribution. We're going to calculate an arithmetic mean. We're going to sum the observations, divide by n minus 1. So in this case, if you sum all these products, you get 180.67. If you divide that by n minus 1, or 5 in this case, you get a covariance of 36.13. And I want you to note that this is a positive 36.13. The greater the positive covariance, the greater the tendency of the two sets of numbers to be on the same side of their mean at the same time. If they're both on the upside of their mean, a positive times a positive is a positive. If they're both on the downside, below the mean at the same time, a negative times a negative is also a positive. So the greater the positive covariance, the greater the tendency of the two sets of numbers to be on the same side of their mean at the same time. They could both be at the same time on the upside or the downside of the mean. It wouldn't make any difference. If covariance were negative, you'd be multiplying a positive by a negative more often than not. Which means if they had a negative covariance, that means that the two sets of numbers tend to be on the opposite sides of their means at the same time. One's given a positive deviation, while the other's given a negative deviation at the same time. A positive times a negative would give you a negative. And again, since this is positive now, you would say the two sets of numbers tend to be what? On the same side of their mean at the same time. Either both giving positive deviations at the same time or producing negative deviations at the same time. Now, as I told you, covariance can take on any values between positive infinity and negative infinity. Again, a pretty wide range. So the question at this point is 36.13, is that a large positive covariance or a very low positive covariance? Answer is, we don't know. There's no way to know that. To get a better handle on that now, we calculate what's known as a normalized covariance term. We calculate the correlation statistic. And the correlation statistic is the covariance between the two assets divided by the product of their standard deviations. So we're going to take the covariance, 36.13, And we're going to divide that by the product of the standard deviation. The standard deviation for the security is 6.41, and the standard deviation for the market is 6.89. Now, that gives you the correlation coefficient, which in this case is a positive 0.82. That's important because the correlation coefficient can only take on values between positive 1 and negative 1. It can't be 1.6. That doesn't happen. In statistics, when you normalize something, that means you're putting a boundary on the value of the statistic. So for correlation coefficient, it's a normalized covariance term. It can only have a value between positive 1 and negative 1. So when we look at the correlation coefficient for these two assets, it's a positive 0.82. Okay? That means that's a pretty high positive correlation coefficient because the highest number it could be is 1. So it turns out that this was a fairly high covariance term, whether we knew it or not. But that's the correlation coefficient. And in investments and business now, if you're going to add assets into your portfolio in investments, or if you're going to add assets onto the balance sheet of a corporation, you want to add assets that have, low or negative correlation, low or negative covariance. But again, because covariance can take on any value, we tend to use the correlation statistic. And again, in this case, this would be a very high positive correlation. These two assets, you wouldn't get much diversification benefit by combining these two assets. This equation, this deal that we're going through here now, how well does knowledge of the market return explain what the security return is doing? Well, to get an idea of that rather, we calculate what's called the coefficient of determination, what's often referred to as R squared. R squared now is simply the correlation coefficient, the little r squared. And so if you take 0.82 and square it, you get 0.67. R squared can only take on values between 0 and 1. You can't have a negative R squared, and you can't have one greater than 1. If the R squared had been exactly 1, that means knowledge of the market would explain 100% of the return of the security in this case. In this case, it is only explaining 67% of the security return. Now, though that's pretty good really, the other 33% or so is explained by something else. We don't know what that is, but it's explained by something else. The beta statistic, a very common statistic. You'll find this in lots of investment literature, in value line, lots of places. And the beta statistic tells you the risk of the security relative to the market. Just so you understand, if this security had a beta of 1, that would mean that the security is taking on 100% of the risk of the market. It's got the same volatility. If we take on 100% of the risk of the market, then we would like to get 100% of the market's return. Okay? The beta in this case is 0.76. Now, understand with beta now, in investments and business, the greater the beta, the greater the risk. So the greater the beta is above 1, the greater the risk of the asset. If you have a beta less than 1, which is what the case is here, betas less than 1, assets with betas less than 1 are referred to as defensive assets. In this case, a defensive security. And in this case, 0.76 means you're taking on 76% of the return of the market, or the risk of the market rather. Therefore, you would require what? 76% of the market's return. And we'll talk more about correlation and coefficient determination and beta in another video, but I want you to understand how to calculate these things right now. The beta statistic, the way you calculate that now, Beta is defined as the covariance between the stock and the market divided by the variance of the market. So if you take the covariance, 36.13, and divide it by the variance of the market, 47.47, you get the beta of 0.76. So beta is the covariance between the stock and the market divided by the variance of the market. And again, covariance, correlation, coefficient of determination, beta, those all look at the interrelationship between the assets. How would you, what decisions would you make about combining those assets onto the same balance sheet of a company or putting those assets together in an investment portfolio? We're going to talk more about some of these statistics here in a later video.